In this video, we are going to go over parallel and perpendicular lines. Parallel lines we've talked about last week. They are never going to intersect because they have the same slope. So parallel lines have equal slopes. So we have this green line right here, which is y equals negative 3x minus 7. So since we know the slope is negative 3, all we need to do is find the b value. So we're counting by 2's. So 2, 4, 6. So it's in between 4 and 6, which is 5. So then if we try to write y equals negative 3x plus 5, let's see if it covers it. And it does. So these lines never intersect because they are parallel. And that means no solution. And that's going to be the same for slide 2 and slide 3. So these slopes are parallel, well, these lines are parallel. So we're going to use this equation, 2 over 5, because that's our slope. We know it's going to be the same because we're talking about parallel lines. And now we have to look for the orange dotted line. It looks like we're increasing by 1. And let's try it. Okay. They will not intersect because they are parallel. Means no solution. Now I will let you do slide 3 on your own. And the same thing with slide 4. Slide 4 is just an observation. What do you notice? What do you wonder? Now we're going to get into the new information. Now last week we talked about lines intersecting. So we have this graph and we have 2 lines that intersect right there. Well, sometimes the lines that intersect are very special. They intersect at a 90-degree angle. And if they intersect at a 90-degree angle, we call them perpendicular. Now, how we can figure out if 2 lines are perpendicular are if their slopes are opposites. So one's positive, the other one's negative. And then reciprocals. Reciprocal just means you're going to make the numerator into the denominator and then the denominator into the numerator. Or you can think about it as flipping the number. So let's see what we can do on slide number 6. So we have this blue line and we are trying to make the red line match up on the dotted line so it becomes a 90-degree angle. Now we're going to use the slope 1 over 3. Now there's 2 things to make this line perpendicular. So this upside down T means perpendicular. So we need the perpendicular slope to be the opposite. So this was positive. So I need to make a negative slope. And then I need to flip the number 1 over 3 into 3 over 1. And 3 over 1 can be simplified, or negative 3 over 1 can be simplified as negative 3. So all I have to do for this is to change my slope, and I know that my lines are now perpendicular. Now to go along with the system of equations, if they intersect or not, we want to hover over this. And then our x value is negative 0.9. And then our y value is 0.7. So the intersection is at this ordered pair. Now in the next slide, we're going to do the exact same thing. The blue line has a slope of negative 1 over 2. So to make it a perpendicular slope, we need to change the slope into a positive because it was already negative. And then we're going to flip the fraction. Numerator becomes denominator, denominator becomes numerator. And then 2 over 1 simplifies as 2. So that's all we're doing for this problem. Not changing the y-intercept at all. And then hover over and click the intersection point. So we have 1.2 and then 0.4. Now you will be able to attempt slide 8 and then reflect on slide 9. Okay, then we're going to do the same thing. We have m equals negative 8 over 7 because that's our number next to our x value. To make that perpendicular, sorry, I should color code this. Make it perpendicular. We do the opposite sign and then we flip. So we're not touching the y-intercept at all. Check my answer. We're good to go. You can do the same thing for slide 11 and slide 12. Slide 13, are the signs of the slopes still opposite? Yes. One will always be positive and the other one will be negative when we are doing perpendicular lines. And the slopes are reciprocals of each other. So they're opposite and they're reciprocals. That's how you know something's going to be perpendicular. Now another way, instead of graphing, to find out if two slopes are perpendicular, or two lines rather. So if two lines are perpendicular, the product of their slopes will be negative 1. So if you don't have a graph and you don't feel like graphing the equations of the line, all you have to do is some simple math. So the slope of one slope is 1/3. The second slope is negative 3. So we're going to get the product of negative 1. If you do the same thing for this one, 3 over 4, multiply to negative 4 over 3, you're going to get a product of negative 1. Continue to do that for slide 16. For slide 17, how do you determine if the two lines are perpendicular using their slopes? Multiply their slopes, and if product is negative 1, and the lines are perpendicular. So all you have to do is make the sign positive and then flip the number 5 over 3. Check your answer. Awesome. Opposite sign, flip the number. That's how you know it's a perpendicular slope. Now for here, you want to identify the slope. So line 1 is 4 over 5. Line 2 slope is negative 10 over 8. Use the calculator if you don't have a graphing calculator at home. 4 over 5 times negative 10 over 8. Yes, it produces a negative 1. All right, let's see if we can find one that is not. So if you multiply 6 times negative 6, that will be not. Alright, since the product of the slopes are negative 6, then it will not be perpendicular. If you multiply these slopes together, negative 7 over 9 times 7 over 9, once again, they do not equal negative 1, so then it's not perpendicular. So you continue to do this, do it for slide 23, multiple choice for slide 24. Slide 25, the same idea. Slide 26,